Yes, so also welcome from my side. This should originally was planned to come first, this presentation. And today I'm going to introduce just the whole packaging world, so to say, and give you some general impression on the use of packaging and also the necessary technical parameters. So just to give you an outline of my presentation, I will give you a short historical overview, very brief. The significance of packaging is an important thing. What is packaging able to do, and what is it often being accused? Mainly creating waste, but we have many different aspects that are very positive on the other side. I will tell you a little bit about the basic packaging terminology, because this is important to understand the other people from other disciplines, especially when you are dealing as food engineer with packaging engineers and vice versa. So it's always good to have the same language. The packaging functions are extremely important because they describe what packaging is doing and some conclusions in the end. Let's start with the development of the packed food we have today. Today, we are able to buy packed food in the retail. The packed food usually has a long shelf life, and in most cases, and it allows us to store it at home for quite some time. We don't have the need to get new food so often, so this storage capacity is very important for our society. This was different some centuries or even thousands of years ago, when hunger was very abundant and people were not able to get food at all the time. So at that time already, let's say 10,000 years ago, they invented ceramic pottery already for storage of some not so perishable food, something like, let's say, olive oil, for instance, which can be found still in archaeological sites. And yes, and they also had some traditional methods to make food more durable, like salting, drying, cooling. That's the good old way to do it. But in many cases, the food treated by that way didn't last too long. So later on, even before Christ, we had the development of glass and paper. A lot of centuries came until we had to see tin plate as the first, let's say, modern packaging materials. Then again, 1 century later, we came to films. Cellulose film was the first one that appeared on the stage. And later on, and you see this very rapid development in the last centuries, when all the plastics we are using today have been developed step by step. In the same time, we had the mechanical methods of manufacturing. We had mechanized paper mills. Also 200 years ago, the principle of injection molding that we are using for making plastic crates and other plastic parts is already about 150 years old. Also corrugated board and so on. So you see that much of the progress already took place in the 19th century. Then here's the plastic age, starting in the 1920s with different ways to process plastic into packagings, and finally also some more specific technologies. This put together with food preparation methods like vacuum packaging, for instance, heat sterilization, leads us finally to packed goods with a relatively long shelf life, which then can be sold in stores, in self-service stores, and it's not very long ago that self-service stores appeared in Europe. It's about 70 years ago. In the US, they started already some decades earlier, and the first prepacked goods that have been sold appeared already 150 years ago. So just a very brief introduction. The basic messages out of this is that it needed the technical progress on all the different routes that I showed you, and all these kinds of progresses had to be put together finally to make our technology that we have today. Another view on the packaging and food chain is this, and I think it's important, if we are talking about circular economy, also to have a look at this scheme. So we have the product chain and we have the packaging chain. The packaging chain is starting with the raw materials that are used for packaging. We produce packagings. The food is done in a similar way. We bring it together at this point with packaging, retail and consumer. These are the points when food and packaging are together and where packaging applies its function. And in the end, they are separated once again when we either use the food or we, in many cases, we dispose of it. That's also happening. Should be minimized, but unfortunately we still are on a very high level there. And down here we have also the recycling or recovery of the packaging waste, which also has to be improved quite a bit. What's so important here is to have the real look at the product, the product and the packaging together, because this determines the packaging function. It's not important or not so important which materials you are using or which methods you apply afterwards in the recycling scheme, for instance. But here, when both parts are put together, there's the function that you have to look for. Okay, we have different types of packaging as well. When we are talking about food, we usually think about consumer packaging. So this is the packaging that you are buying in the store. But in between, we also have industrial packaging, like, for instance, intermediate packaging for food constituents, which, for instance, the milk industry sells milk powder to some food producers. And this is another type of packaging which practically doesn't appear in the public because it vanishes somewhere in the chain. Anyhow, when we look at those different packagings, they all need different packaging functions, and this is something I'm going to talk a little bit about. But first, the role of packaging in food quality keeping and also avoidance of food losses. You will probably know also from statistics from the United Nations, you may get the figures very easily, that we have a very high fraction of food losses in non-industrialized countries, not only due to lack of proper packaging methods, but also due to lack of proper storage methods and many other things. And vice versa, in our industrialized countries, the main source of packaging or food waste is not the structure in the industry, not the logistic chain, but it's simply the consumer. There's losses up to 40%, which are simply done by the consumer, who either does not understand, for instance, the best before date, and there are many other reasons. And basically, if you ask me where is the highest option, the best option to reduce food waste, we have to look at the whole chain. And this is something that is already that already appeared in political issues. The European Parliament already made a resolution on resource efficiency, and the basic targets are to reduce food waste by 30% up to 2025 and to 50% by 2030, which is quite ambitious, I think. But they also say, and this is very important for the packaging, that there is a positive contribution of food packaging. The problem, however, is how much does packaging contribute to the reduction of food waste? Can you give a figure on that? And the simple answer is, unfortunately, we cannot give an exact figure so far. We can only guess a bit, and I'm trying to do this just by looking at the figures from the FAO. There's figures from the FAO which have been raised in 2012, dealing with all the different food losses along the food value chain. And just the non-industrialized countries, we see that from the harvesting over to the next step, the so-called post-harvest, we have losses for a limited number of products, by the way. So it's not all the products, it's just a number of selected product groups, between about 4 and 15%. Okay, doesn't look so much, but the problem is that those figures accumulate. So when we process the food and it enters up in the next step, we have between 0.4 and 18%, everything valid for the non-industrialized countries. Take care to find conclusions, because they will be different for the industrialized countries, which I will be showing you next. We have then the processing step, which also gets some losses. And just remember those figures when you see the next slide. Maximum of 12% of the food is lost here in total. And then before consumption and after consumption, we have less than 10%. So all these losses sum up to between 18 and 66%. So up to 2/3 of the food is lost. And now our view to the industrialized countries, if we look to the end, the figures are nearly the same. A little bit less on the maximum, a little bit more on the minimum. But you see here the big issue, the food losses at the consumer. And this is something we can think about to discuss where the benefits of packaging in our industrialized countries may be located. They will be not located here, because here there's still no consumer packaging applied, because it starts just at this point. But afterwards, the consumer determines how efficient the packaged goods are treated. And in many cases, this is not done properly. You know it by yourself. when thinking about the reasons why you throw away food. This is very often done without a very good reason. So, some interim conclusions. We have the packaging in most products sold, and they have their specific function. They can reduce product losses. We still cannot tell on the average how much it really does, because we don't have the direct comparison packaged versus non-packaged products in most cases. The protective function of the packaging is the most important role of packaging and the benefits it does. Okay, so far for this. I then go to our next chapter, packaging terminology. This is important just when you discuss along the chain. So when we talk about a packed good, finally, I start at the end, we have a so-called package. The package is the combination of the packaging and the article or the product. And to confuse people, when we put together the packaging as something that's been made from materials and the article or the product, we do this in an operation that's also called packaging. This confuses several people. This is done via packaging machinery, and in the end we go to the package. Before, we have the packaging, which is made from packaging material. It can be something else, but in most cases we have to deal with a container. You know what this is. There's another word for it if it's not a real container. It's called receptacle. That's a little bit kind of an artificial word. This is also something that's able to take something up and to avoid that it's spread over the ground, so to say. And in addition, we have packaging components. Packaging components are things that can be separated easily, something like closures or labels. Whereas if you have a multi-layer film that consists of different plastics, we don't talk about packaging components, but we talk about packaging constituents when they cannot easily be separated. So just to remember this. And to show you that things are a little bit more complicated, what you usually see when you go into the store, you see the article or the product usually in its primary package. You can see it sometimes also in its secondary package when it's, for instance, in a tray or in a crate. Sometimes things are also sold in that way, but there are many more steps that can be made, and in the end we have a transport package and the unit load. The unit load is that what's being finally transported, or either by ship or by a truck. So just to show you this principle, we have the primary packaging, we have the secondary packaging. Sometimes you buy both together, but you will in most cases never buy a total unit load. Okay, some may do so in this example, but that doesn't happen very often. And in this case, this unit load consists of a tertiary package, which is the pallet, and together with the secondary packaging and with some additional components, which are the securing straps, which are wrapped around here. Sometimes it's even a little bit more complicated. We can also have a quaternary package when we are dealing with ship transport, for instance, and when those pallets which are filled are then again placed into a container, just to make it a little bit understandable what we are talking about. So, some more terminology. We talk about packaging material. I think this is quite obvious what this means. And we also talk about the container or the receptacle. And these are the definitions from ISO, which are being used to define this a little bit more in detail. I won't go through this in detail because it would be a bit tedious. It's quite easy in the end to understand packaging material, that's obvious, and container or receptacle, that's something where you can put the products in when you fill it. So we also have this difference between packaging components and packaging constituents. Packaging components can be easily separated. Packaging constituents can not. And in some cases this creates problems. For instance, if we would like to apply recycling in a higher amount, then it's very often the case that we cannot separate the packaging constituents, and in the end we get a packaging material that's not recyclable. This is another story, but it's important to see the difference between those things. Just one example to illustrate this. In Germany we have as Olivier Vitrac already told you, a very well established returnable glass bottle system in the beer sector especially, but also in the fruit juice sector. And this is just one example of a whole beverage packaging system, which starts with a product. And this is in the end that what you can find on a unit load, which in this case is a filled pallet. So you will find there 384 liters of fruit juice. It consists of 384 1-liter bottles, which is the primary packaging in this case, or the container. We have a component of this in form of the label, in form of some other things to make it a little bit more appealing. We have the closure, which is an important component of the package. And then these things together are put into the secondary packaging, which is the plastic bottle crate. On our pallet we have 64 of them. We have the pallet and something in addition to make sure that things do not fall down on the truck transport. So this is a typical packaging system. What's the importance of this? If people are discussing about waste created by packaging, they usually look just at the primary package. They forget in many cases that behind the primary package there's a lot of other packagings. And even if you buy unpacked goods in special stores in Germany, they are opening at a quite high frequency in many cities, then there will be still some packaging that is needed to transport the goods to the store. So there's many things that are unseen, and in the end, if you would like to optimize the whole system, be it in terms of environmental properties or in terms of money, then you have to look at the whole system and not at a single component. Some interim conclusions and the next step already, which comes then the packaging functions. If you have already heard about packaging, you will have heard about the famous so-called PCCC. That's what all packaging engineers over the world tell you if you ask them about the packaging functions. PCCC means protection, containment, communication, convenience. And I would say you have to add a fourth C, which means conservation. Conservation of the environment, which means that the packaging function also has to look at that. So, how to address this a little bit more specific and in detail? We look at the single parts of this whole packaging functions. We start with protection. What has the product to be protected from? It usually has to be protected from influences coming from the environment. Many foods are sensitive against oxygen, some are sensitive against water vapor, others are sensitive against water losses. This is something that goes into the other direction. Some products are sensitive against light or all together, and definitely mechanical loads are not good for anything. But there's other things as well. If there is, for instance, a paper package, you may also have particles entering the package. You may have insects, which is not a nice experience when you have them in your kitchen, but sometimes this also happens. You have contaminants from the environment, for instance, pesticides, which may be sprayed in some storage rooms, and heat is another effect. But these things here all come from the external world, but there may be also something that comes from the packaging itself, meaning contaminants that are already included in the packaging material. This is something which is very important. There's a lot of EU legislation on it, and Catherine Loriot already told a lot about this. So bear this in mind, and this is one of the, I would say, best regulated issues in packaging that we have in Europe. Good, so to repeat this, we have the environment, which gives us external influences, and we have to select the type of packaging according to the product on the one hand side. What are the sensitivities of the product? Not all products have the same sensitivity against external influences, and the performance of the packaging has to be adjusted to this. And the packaging itself, and for this we have the requirement of a certain inertness, and for this there's several EU regulations dealing with this. Okay, so just to conclude on this part, we have many effects that can be happening to the packed goods, substances, energy, and also biotic effects like the non-wished insects or many other things like microorganisms, for instance. The main thing here is insufficient protection shortens the shelf life and increases product losses. This is, I think, not to be discussed about. The only question is, to which degree does this happen? And this is difficult to calculate. We still don't have enough figures about this. Next function, containment. What do you expect from a packaging when it contains a liquid? The simplest thing is it should not run out. So for instance, if you have, and this is, symbolizes the degree of failures that are able to avoid this. If you reduce the number of leaks and the size of leaks a little bit, you can already avoid the loss of powdery ingredients because the powder will not pass through anymore. But still water will be passing through. When you again reduce the size of possible pores or leaks, there's still fats and oils and other liquids that may go through this. If you reduce this further and you think that you have achieved a perfect packaging, then it still can happen that corrosion occurs, especially in the case of metal packages. So you may think there is something like the perfect package. In fact, in many cases, it does not exist, because if you think about plastic packaging, plastic is always permeable to substances. It depends on how much is permeated. It can be a very low number of molecules or quite a lot. And this is a thing what we call permeation. Permeation means that something can pass through an intact material. And in plastics, we have to deal with CO2, with oxygen, with water vapor, with flavors, with a lot of substances. We don't have to deal with this in the case of metal packagings. If they don't corrode, they will be perfect. If we are talking about glass packagings, for instance, people think they are perfect, glass packagings, but unfortunately they have a closure. And in the closure, we have a sealant, and this is usually a polymer. So also in this case, the packaging is not perfect. Remember this when you think about the function of a packaging. So for instance, we have this leakage, which may happen either because there are pores inside or because they are formed later on by corrosion, for instance. This is the example of a can. I took this photograph myself a couple of years ago. This kind of can still exist where you may have corrosion inside. Unwanted, but really not a nice thing. So, containment, we have to talk about leakage, we have to talk about permeation, and we have to talk about corrosion. And you have to avoid, to a large extent, these three phenomena. Next step, communication. What's important in communication? And I think the most important thing for you as a consumer is to know how much is in the package. What's the quantity that has been filled? And this is directly related to the packaging process. If the quantity is not correctly dosed, the label tells you a wrong thing, which should not be happening. And also for this, we have EU regulations that are related to the amount that's been filled in and the amount that is given on the outer side, the indicated amount, and those should not differ too much. And what's also to be indicated here is the date of minimum durability or the use-by date. Both are also regulated by European regulations. Just an example for this communication, the label for an orange juice. This is the contents. It should be exact within certain limits because it cannot be 100% exact. There may be some ingredients that have to be indicated, a declaration, for instance, of vitamin C. If there is not enough vitamin C in the bottle, it would be a wrong declaration. And also here you have the date of minimum durability, which should be secured. And this is directly related to the packaging function. This is also directly related to the packaging function in many cases. And this is related to the function of the packaging process. So, okay, this is a thing you all know, probably. We have a use-by date for many foods. We have a date of minimum durability. And usually the use by date is indicated as use by. The date of minimum durability is usually indicated by the best before date. But not surprisingly, about 1/4 of all the consumers do not really know what this means. Important to know this, because this explains why so many food losses occur. Because people don't know that they can, for instance, still consume some food after the best before date. Many people think they have to throw it away just at the date when this is expired. On the other hand, if you have a use by date, be careful if this is expired. But this is more clear and obvious. Okay, also the contents in the communication. 150 grams followed by this letter E. Or again, this letter E followed by 33 centiliters. This means that this is in conformity with this EU regulation, and this means that the contents is within a certain range of specification. I won't discuss this too much in detail, but a little bit, some years ago, someone tested it, and already as many as 6% and 5% of the solid food packages, 6% of the beverages were out of this range. So this is reason for good packaging equipment to be applied to avoid these negative things. And if you would like to look at this a little bit more in detail, you can have this table, and this will tell you, for instance, that no more than 2% of the packages may fall below this negative error, meaning if you buy a package where 50 grams have been indicated, you should not find more than 2% which are below 41. Yes, not 41, but 44.5. It's 9% is 4.5 grams or milliliters of this amount. So for some people, it's a hobby to check how much is in their package. And if you like, you can make your own statistics at home. Good. So this is something that's communication, that's required communication because it's regulated. And there's a lot of things you have to take into account to fulfill them. And it, once again, depends on packaging and the packaging processes. Fourth chapter of this, convenience. And this is something which is very often discussed. People think, why do we need this high factor of convenience in packaging? Is it just due to the case that we as consumer have become so lazy that we don't like to deal with our food anymore and we like to have it already prepared? The answer is yes, this is the case. And if some company produces a package that allows more convenience, you may imagine that many people may resist this, but in fact it's not true. In fact, they sell more by this. So this is one reason that convenience is an important element of packaging. The companies would like to sell their product. On the other hand, it also helps you quite a lot in maintaining the food quality. For instance, this is a view inside my refrigerator at home. You see the stacked fruit and vegetable, and how would you else be able to stack them in a refrigerator in that way? Difficult. You could tell me, okay, consume them faster, but unfortunately we are only 2 persons at home, and therefore I prefer to have them on a relatively high quality for a longer time. So this reduces food losses. This reduces food losses, although it's also a very convenient packaging for the consumer. Reclosability also reduces food losses. So some figures exist. For instance, from an Austrian retail chain, they told that if such fruit and vegetables like strawberries are packed, they reduce the losses up to a factor of 12, which is quite a lot. Or also here, reduction of food losses from 5% down to 0.4%. That's not bad. And meat, if you pack it in the relatively new vacuum pack, you reduce the food losses versus modified atmosphere packaging, which is also already a convenience packaging, from 12% to 3%. And these are only the food losses that are registered in the retail trade. That there's no idea why and how many of the food losses directly appear at the consumer. There are figures around this, but these figures are just being made by asking the consumers. And usually if you ask a consumer, it's not very likely that he tells you the truth, because it's difficult to tell it. You don't remember what really happened, for instance. Good, so convenience is something that's very ambivalent. We don't really like it when talking in environmental connections and environmental context. We think that packaging should be simplified. Yes, that's true, but on the other hand, it also gives a benefit. And it's difficult to really find the right way, because facts are not too much available. So also environmental functions. Avoid food losses. This is the major function of a packaging. And if the packaging is designed in a good way, it is really doing a good job. Just for comparison, this is a view into my so-called yellow bag. We have this collection system in Germany, and what you see here is plastic packaging. It has done some good effect, but afterwards it creates a problem. That's waste. And how to deal with this? This is a big European work for the future. Just to give you some insight into this, a very old story, it's more than 20 years old, was done for the UK market. And this guy named Koyman in 1996, he collected statistical data for the UK food supply, and he added up all the energy equivalents that have been used to produce something, up to the food production, up to the for the primary packaging, for the transport packaging, and so on, and also the energy that's needed at home for storage. That's your fridge at home, and this is the cooking at home. And if you add everything together, it's not much that packaging contributes to this. It's roughly overall about 11%. And this means that if you try to reduce the effort on the cost of reducing, of increasing food losses at this point over here, it will be probably counterproductive. You will probably create more environmental loads than less. So difficult for the exact case to tell where the optimum is, but it's definitely not at zero packaging. Some figures for our packaging waste. You see that paper and cardboard plays the biggest role. Then we are dealing with plastics, with glass, and so on. And if we are looking at the development over the years, we see that we have a practically continuous rise since the last economic crisis in 2008, 2009. So packaging, the amount of packaging increases. This is where the future job for us starts, to increase the efficiency of packaging and to make a proper use of this whole packaging waste. And this can also be seen from this representation. It looks a bit confusing, but these are the figures. If you look to the total here, it tells you the whole amount of packaging that has been recovered by some or the other way. So this here is the lower figures, the lower parts of the bars are recycling. Here we have the incineration with energy recovery. And here we have also another way of energy recovery. And there's other things, but I don't want to go too much into detail. But what you see from this representation is that we have an extremely large spread of the practice in Europe. For instance, look here at Malta. The whole recovery is far below today's recycling target, whereas at Belgium or Denmark it's far above. And this is our recycling target that has been set today for the EU. The green bar here is the target figure for 2025 and the red upper limit for 2030. And you see that it's not too ambitious for many of the countries, but for other countries, there's still a long way to go. So it's difficult, and you should have a close look at all the figures before judging on the practice. So just some figures for recycling targets in Europe and in Germany. I won't go through them in detail, simply to read them, and you can find this in the internet as well. And finally, some conclusions from that. Most people don't know anything about the positive environmental function of packaging. And this is something we have to teach people about. Also to get to have the right view at all the products and to treat the products inside also in the right way. For instance, not throwing them away before the best before date or around the best before date. We have a problem in packaging waste because the packaging waste creates the highest amount of plastics waste from all the different sectors. So this is really daily to be seen. This is, by sure, this is a problem. And we have to look for a proper balance between those two things. Looking for recyclability, looking for recovery, looking for avoidance of packaging, but also looking for the proper packaging function. Finally, we need those packaging functions in many cases. We find packaging mostly as consumer packaging. That's why everybody knows about this. We need it, yes, but we also need to understand what is the needed function and what could be reduced in packaging. That's why we have to look very closely on the packaging functions. And therefore, also on the waste management side, there's still a lot that can be done. So, I seem to have been in time. Thank you very much, and if you would like to put up some questions, please don't hesitate.